All right, today we're going to look at some examples of compound probability using Venn diagrams. Our topic is compound probability, and our objective is the student will be able to understand and apply the concepts of compound probability. And again, we are working with Venn diagrams. We're used to seeing Venn diagrams as just two circles, but actually there's an added piece for this. So the two circles represent whether something is one thing or another or both, but then this outside region represents something that is not included in those circles. So we're going to look at example 1. It says, in a survey, 100 adults are asked whether they like coffee, which is represented as C, or tea, which is obviously represented as T. The Venn diagram shows the results of the survey. It says, part A, find the probability that a person does not like coffee. Part B, a person who likes coffee is chosen. Find the probability that they also like coffee. And then part C, 2 people are chosen at random. Find the probability that they both like coffee. So let's go ahead and look at part A. The probability that a person does not, not is important here, does not like coffee. So the number of people who do not like coffee are represented by the people who like tea. That's obviously part of it. So 25, because they don't like coffee, they like tea. The rest of the people who do not like coffee are actually represented outside of the circles. They're represented by these 16 people who said they don't like either. They don't like coffee or tea, so they're counted in this as well. So that's going to be a total of 41 people. So we had 41 people out of the 100 people asked that said they did not like coffee. And this is going to be our probability, 41 out of 100 people. The probability that they do not like coffee. So I'm just going to say not C. Okay. Part B, a person who likes tea is chosen. Find the probability that they also like coffee. So we're going to start with this first. Somebody who likes tea is chosen. We just figured out, we just talked about the people that like tea. The people that like tea, there's 25 of them here. There's also this middle group who likes both coffee and tea. So they do like tea. That's important. So these two groups, we have 46 that just flat out like tea, 25 that just flat out like tea, and 46 that like both. So that's going to give us 71 people that enjoy tea in some way. So there's 71 people to choose from that like tea. These are our tea people. Now we're going to find the probability that they also like coffee. So right now we only have 71 tea people. How many of them also like coffee? That's, again, going to be in our both category. So I have 46 people that like coffee and tea out of the 71 people that like tea. So 46 out of 71 is going to be our probability. So probability of coffee and tea. 46 out of 71. Two people are chosen at random. Find the probability that they both like coffee. Okay, so random. That means we have the entire I'm going to change color here. That means we have the entire 100 people. Random. Means we get 100. So the probability that the first person likes coffee. The probability that they like coffee, we have 13 people that like coffee, and we also have 46 that like both. So that's going to give us a total of 59 people out of 100 for the very first person. Now that we picked the first person, we have to look at the second person. And because my first person was 59 out of 100, I'm not going to have as many people to choose from because I took one out. So I'm going to actually this time only have 58 out of 99. And what I'm going to do is I'm going to put both of these. I'm going to use both of these to find my probability. So the probability that they both like coffee is going to be 59 over 100 times 58 over 99. That's going to get me 1,711 over 4,950. And that's going to be 0.346. Or about 34.6% chance that they both end up liking coffee. Okay, let's move on to example 2. In example 2, in a survey, 60 people are asked if they own Airpods, which are represented as A, or Beats, which are represented as B. The Venn diagram shows the results. So a person is chosen at random. Find the probability that they own Airpods. Okay, so Airpods. Airpods are represented as A, so we're looking at this number here, that's 29. And we're also looking at our middle number is 6. So they own both Airpods and Beats in the middle, if they're in the middle. So they own Airpods. So we have 29 plus 6. That's going to give us 35. So 35 out of the 60 people own Airpods. And we can reduce that. Both of these numbers are divisible by 5. So that'd be 7 over 12. The probability that they own Airpods. Find the probability that they own Beats. So kind of the same idea here. Beats are represented by B. So we're looking at the B number and the number in the middle. So 21 plus 6. That's going to get us 27. 27 over 60. Both of these numbers are divisible by 3. So that'd be 9 over 20. The probability that they own Beats. Find the probability that they do not own Airpods. Okay, do not own Airpods. So this is kind of like in example 1 where we looked at the people who do not like coffee. So people who do not own Airpods would be the people that have Beats and the people that have neither. So we have 21 plus 4 out of the 60 people. Again, both of these numbers are divisible by 5, so we're going to have 5 over 12 is the probability of not AirPods. Lastly, a person who owns Beats is chosen. Find the probability that they also own AirPods. A person that owns Beats. We're going to start there. Okay, so the probability that they own Beats. So the people, pardon me, the people that own Beats are represented by obviously 21 and then 6 in the middle. So that's going to be our 27 out of 60, but we're not going to reduce yet. And then the probability that they also enjoy, the probability that they also enjoy, or they also own AirPods. So for that, what we're doing, the probability that they own Beats is going to be 27 people, not out of 60, pardon me. And then we have the probability that they also have AirPods is going to be the 6 people that also own AirPods. So this is going to be 6 out of the 27. And that's going to be the probability that they own Beats and AirPods. In example 3, there are 100 students in the 9th grade who study art. That's represented by the letter A, and 29 students who study biology, represented by the letter B, and there are 13 students that study both subjects. We're going to first show this information in a Venn diagram. So, just going to draw 2 circles. Okay, this is going to be art. This is going to be biology. There are 50 students that study art, 29 that study biology, and 13 that do both. And remember, we have 100 students total. So what we need to do is add these up. So we have 50, 13, and 29. And what we need to do is subtract those numbers from the 100 to get the people that do neither or study neither. Okay, so we have 100 minus 50 minus 13 minus 29. That's going to leave us with 8 that study neither. Oops. And this is our Venn diagram that we're going to be using. So, a student is chosen at random. Find the probability that the student studies biology, but not art. Okay. So, biology is represented by these 2 numbers, but not art means I actually need to get rid of the 13 because those students also study art. So the probability that they study biology is going to be 29 out of the 100. The probability that the student studies neither biology nor art is going to be represented by this little 8 that's out here by itself, because it doesn't belong to biology, it doesn't belong to art. So that would be the probability of neither is going to be 8 out of 100, which we can divide both of these numbers by 4. So that's going to be 2 over 25. And then part C, 2 students were chosen at random. Find the probability that they both study art. So first off, 2 students were chosen at random. Find the probability that they both study art. So 2 students that study art. So the first student that studies art, so probability of first art, is going to be 50 plus 13 over 100, or 63 out of 100. So then the probability of the second art is going to be 62 out of 99. So the probability that both study art is going to be 63 over 100 times 62 over 99. And if we multiply that out, I have 63 times 62. That's going to be 3,906 over 9,900. And if I divide, I end up with 0.39, which would be about a 39% chance that choosing 2 students and getting them to where they both study art, a 39% chance. All right, and that is a little bit of compound probability with some Venn diagrams.